So 4.1 is ionic bonding, and we're going to divide this up into two parts. We're going to talk about what ionic bonds are, and then we're going to talk about the structure of ionic bonds. So ionic bonding and structure, you have valence electrons that are transferred. So remember, in metallic, they form that sea of electrons, but in ionic, they're transferred. And so we have ions that are formed, which is where ionic bonding comes from. You have a cation, which is positively charged. It's typically a metal, however there are some positively charged polyatomics. And then you have the anion, which is the negative charge. These would be nonmetals or a polyatomic made of nonmetals. If you have a transition metal, it's going to form different charges, and each of those charges would correspond to different properties or like color of that transition metal. So like copper can either be blue or green depending on the charge that it's carrying, +1 or +2. So in our picture here you can see the charges of our elements that don't vary. The ones that are blacked out there are ones that have various charges, so you would have to use a Roman numeral. So Roman numerals are used for transition metals and post-transition metals, which are the ones underneath the stair step. Notice that silver and zinc and then cadmium have specific charges. We talked about silver and zinc last year. Cadmium might be new to you, but that also has a charge of 2, just like zinc does. Polyatomics, make sure you've memorized these. They were given to you during your summer assignment. I will post a link to them as well on this page in Canvas. If the polyatomic ends in 8, that's the quote-unquote normal amount of oxygen. So our example here is chlorate is ClO3, so 3 would be the normal amount for the chlorine polyatomics. ITE means it has one less than normal, so chlorite is ClO2-. They still have the same charge, it's just you're taking away an oxygen. You can then add prefixes hypo and per to go beyond those two. So hypochlorite is 2 less than the normal amount, and then per8 is 1 more than the normal amount. An ionic bond forms when oppositely charged ions attract to each other, so you have to have one thing giving away the electron to the other, which is why the electrons are transferred. And in this picture you can see that it's sodium and chlorine. Now that's a perfect match because sodium has 1 valence electron and chlorine needs 1 valence electron. The process of forming ions is called ionization, so a lot of times you're going to see that word ionization, and it just means forming the ion, losing the valence electron or gaining the valence electron. Now it's once these are formed that the electrostatic force can create that ionic bond. So that positively charged ion and that negatively charged ion are attracted to each other, and that's the electrostatic attraction between the ions. The compound itself has to be electrically neutral, which is why we cross our charges when we write the formulas for ionic compounds. And then we also reduce if we're able to reduce the number of cations and anions. Now this goes back to Chem 1, so I'm going to just leave you practicing naming those and then writing the formulas, so you can pause, see if you can write them out, and then I'll show you the answer. Okay, so here's the answers. If you have questions about any of these, make sure you leave a note on the Google form.